Hello everyone. My name is Aki Kopra and I work as a design manager for a Finnish civil contractor called Kreate. And in this project, my job was to coordinate the design to go along with the construction, and also I was a responsible BIM coordinator in the project. We heard a previous presentation, a really challenging and beautiful bridge from Turkey. And one thing that really struck my ear was that the 3D models weren't really handed over to constructor. But here is really a different perspective that as a main contractor, our role was to coordinate the BIM and the design, and it was my responsibility to do that. So this is a completely maybe new perspective for many listeners, and maybe because of that holistic approach in BIM coordination and the BIM collaboration, we won the Global Tekla BIM Awards with this project last year. So I believe it would be nice to hear some of my perspectives on this. So a short introduction about the project. This is part of the Crown Bridges light rail connection in the city of Helsinki, the capital of Finland. And it's a crucial link between the city center and eastern Finland. It's eastern Helsinki. And it's constructed now, and at the moment we're finalizing the bridge project by the end of this year by a joint venture with Kreate, my company, and YIT, which are one of the biggest contractors in Finland. And the client is city of Helsinki. Here you can see the map of the connection, and in the middle there's the Kruuunuvuori silta in Finnish. It's the biggest crossing on the link. This has been a really long project. Started from the design competition in 2011, but now I'm gonna focus on the teal colored phase, which started on 2021, and our project, this construction project, would end in 25, and the bridge will be open for public and the rail transportation in 27. And already in 2011, this was a really groundbreaking project because it started as a light rail project. So in the beginning, almost like 15 years ago, they already wanted to make sort of a green statement that this bridge wouldn't carry any car traffic, only pedestrian and light rail. So it must be also an environmental statement, so to speak. But we started our project in 21 with YIT, and we have these designers for us, Rambo and Sofin Consulting, and the bridge designer is WSP. And this project has something also a lot of other construction, but the main point of this project is this Kruuunuvuori bridge, which is going to be the longest bridge in Finland, also the highest, tallest, and longest standing because of the lifespan of 200 years, which is really exceptional. I could give you a short and longer presentation about the long lifespan and the requirements for quality assurance and such, but let's not focus on that. But that's also a really interesting point in this, our characteristic in this bridge. And then, as mentioned before, the bridge was designed by WSP and Knight Architects as the main architect. It's really, as they say, light, subtle, and airy, and really beautiful one. Here you can see a couple of pictures, visualization and a shot from the BIM, and an actual shot from the construction site. They all look the same, so I think that's a good end result. But I'm gonna give you a short intro in PowerPoint in the slides, but then I'm gonna be brave enough and I'm gonna do a live demo in Trimble Connect and tell you about all those topics: bridge design, workshop design, geometry control, temporary structures, some 4D stuff, and issue tracking, quality assurance data, and so on. So we will be focusing on those in this half an hour. So the BIM is the main design format, and as you can see, there's all the reinforcement is modeled and very thoroughly. Geometry control is also in BIM, so the installation and fabrication geometry was designed in BIM format and IFC and used for measuring on site and controlling the geometry of the installed bridge. A very really new approach in my perspective, I believe, worldwide. It all boils down to GH algorithms, as we know in bridge design. Workshop design, I'm going to tell you about that a bit, about temporary structures, some virtual VDC stuff, as they say, virtual design and construction, simulations, installations. And all the temporary structures such as scaffolding are modeled. We've also used grasshopper algorithms to model the temporary stuff all as well. So also contractor, myself, we have designed temporary structures and modeled them with grasshopper. So it's not only a designer's piece of cake. And some as-built data, quality assurance data, how it's connected to the BIM and how we present it to our client. And something about the site, I'm really running through this because I have the demo coming up. That there's a lot of really deep water construction, big foundations under below sea level. Here you can see a shot from a caisson structure, steel structure. And there you can see in the bottom those piles, impact-driven piles of a diameter of 1.2 meters. So those are like big office buildings, those caissons, and there's 10 of those in the bridge. And then we're building high up, as you saw a couple of pictures. It's 135 meters above sea level. In Finland, that's a huge building. And here you can see some of the beautiful Helsinki city line, skyline. And launch segments, because it was a launch installation in the bridge, with almost 500 meters long. Stay cable segments were installed by sea crane. And we also used IFC for surveying, pointing stuff on the site that we need to measure. And this was all done through Trimble Connect, no external DWGs or DXFs to measure stuff, only IFCs. Yes. So let's go to the actual demo. I believe you can see my screen still. Yes. So, as mentioned before, I have a really holistic BIM bridge design in BIM. There we have all equipments of the bridge, reinforcement. Our reinforcement of course is modeled. This is pretty normal stuff in Finland. I don't know if it's in everywhere else, but in bridge design we really design all the model the reinforcement, and that's also really useful for contractors, so we can extract bending lists and order reinforcement straight from the model using mostly Tekla structures because it's more compatible with bending list production, but also we can use also the object the data table from Trimble Connect to produce those lists and order reinforcement. It's not only IFCs. We have of course. Well, this doesn't have much road construction, but of course, all the water construction and bedrock is modeled and such. So this was a really good starting point for a contractor to start building this BIM based project. And let's see how quickly we can change views. This is also a test for Trimble Connect in real conditions, but luckily we have a Trimble Fox behind the the screen as well, so we can get instant feedback how to handle big models. So now I'm showing you guys some workshop models, and also all the workshop models are modeled and shared in Trimble Connect. No external servers or ways to exchange the model data. And here you can see the workshop models are in different heights or elevation than the actual end product, because they are produced in the fabrication geometry, which of course takes in account all the loads that would be projected to the steel structures before the final stage. And of course, in the spans, they are much bigger, the deformations than, or the pre-cambers than all the supports. And this was then could then be coordinated with the steel fabricator, which used the model also for coordinating their workshop work, and of course extracting quantities and designing welds and such. And our workshop designer Rumble, which did a really good job in creating this in a short time frame, and practically error-free production in workshop design. Then produced all the drawings from here as well, which is quite normal in Tekla world, as heard from previous presentations as well. Okay, let's try another view. So that was about the workshop design. I will not present you guys any drawings. That would be maybe boring in a BIM conference. But let's try. How can we manage to show you guys some temporary structures and geometry control along with some point clouds? Let's see. Pretty good. Yes, this might, in my perspective, is the most maybe the most interesting part of this presentation. That we modeled all the temporary structures, such as the temporary bridge. You can see, which you can see here, and all the piles are then cut with along with the bedrock model in Grasshopper. No manual modeling done there, and along with the bridge geometry, we did that as well. And here you can see a situation from the site, from an aerial photogrammetry that shows the location of the temporary bridge and temporary supports that go nicely along there. And let me just shut down point cloud so you can see better. Here, so here are the temporary supports for the lifted segments. But here you can see a really interesting work that our designer and we did on the site. That the launched steel structure of this bridge was modeled in a installation geometry and produced for us on the site to the site in an IFC format. And here you can see all the different phases where it stopped the installation over the actual piers, and you can see the installation nose there, which is in different phases there. And when we got completed one phase, then we had another phase on the side here, another model phase model for the site here, and you could see that we could use this model to actually measure it on the site. So as I mentioned before, we were using IFC geometry, and then the guys on the site could use these coordinates to actually measure it measure it in place. And our geometry control designer was using sophistic software, and then produced an installation after installation these IFCs along with the actually launched segments. So he would make sure that these next segments would connect the geometry in a correct way to the already launched segment. So that way the quality of the geometry was controlled in every phase. And that is something I think, and our sophistic consultant Atte Mikkonen said also that this is really a new approach. We wanted to try something like this and stay top of the game, as they say, and it went really well. And here you can see another really interesting point of the simulation or the virtual design and construction, that we had this sounded seabed by the pylon, and we had this sea crane dummy models there, and we could check if it has enough clearance that it wouldn't actually hit the bottom of the sea when it brought the lifted segments. And what was really interesting about this installation was that they weren't installed on the site or assembled on the site, but they're assembled actually here in another place in the close to the project. And here you can see the actual segments here on the site. And these were also then measured by IFC and installed in piece by piece. Also, these stay cables, guide pipes on the right angle, and then taken by the sea crane and then carried through the sea to these spots. So even though we installed those by IFC models in a really different location and could check them in Trimble Connect, we managed to actually point those stay cable guide pipes in a really correct location and angle, so they match with the pylon's corresponding guide pipe. That was a really amazing job from the guys and girls on the side. Yes, this could be also a source of a single presentation, but let's go forward. Then I had some scaffolding. Well, let's not go there. But here's a point that we tried using, but we felt that Trimble Connect wasn't really good enough for this. Maybe we have too big models, too many objects, or something like that. But we used this title sharing to track the progress of the site and try to really show our client that which type of structures would be produced, which are underway, which are completed. You can see here these that these actually perform quite well, but it was a really pain in the ass to model or color these objects and show the correct statuses. But so we abandoned this way of working as a 4D scheduling. I mean, it's really informative, but it's to really do it. It's really takes really a lot of time and effort. Maybe in a smaller project or some other tool. But to track the progress of the site, we then used Trimble Connect and these 3D WGs to show the geometry quality of the actually completed structures. Here you can see we have all the models floating over this actual BIM models, and they show the actual location of the structures and the deviations in elevation and XY. And this was the way that we showed our clients also, because we are trying to do this in almost real time. That where this was also a way to show our client that when which structure are completed. Here you can see the pylon segments from the pylon, that the pour breaks that show the pylon from the bottom to the top, and how it's then how we have succeeded in producing it, pouring it to the right geometry. So there you can see it's 19 millimeters or 11 millimeters 9 and such. So it's really good job, considering it that it's 135 meters above sea level and really in rough conditions. So as built models were produced like that, and of course, if the tolerances, a certain structure's tolerance would be exceeded, we would of course create a deviation report, and then we would model a new IFC model along with that. So in that way, we produce the as-built model. But if the deviations aren't, or the geometry qualities under the tolerances, then we wouldn't model anything again. So this IFC models would then itself be good. Okay, but yes, so IFC models were mostly the as-built data when the quality is good. And also, we could track the project progress by using these aerial photos. Here you can see these weird spheres hanging in the air, and these contain links to the aerial photos. You can see that when you click the link in Trimble Connect, then it has the same location as the sphere on the actual site. Yeah, and here you can go back in time, like if we would go like half a year or more, and we can see what it looks on the site. Then there you can see also the tower crane, but today or last week's image, it's already missing. So this is also connected to the BIM as well. Then in this view, I have one interesting point to present to you as well, that we have also the links for the actual quality assurance data. If we take like the foundation for this pier, for example, it has a link to this quality assurance package. Let's see, will it open the M files project bank? Yes, it works. It works, and this document contains all the links to the different documents that then show the quality of the structure, all the material stuff and such. So also this serves as like a handbook or a manual for the lifespan of the bridge as well. But of course, it's up to our client, City of Helsinki, if they wish to use it. Yes. So then I had also something about if you have deviation reports in BIM. Let me show you this, and then we can have maybe some time for questions, like a couple of minutes. So if there were a deviation, like in quality, like this stay cable protection pipe had a hole in it, it's then marked in Trimble Connect to do. As you can see, there's a lot of these. Not all of our deviation reports, but also like packaged quality reports. And here you can have the link for the M-Files project system as well. So this M-Files served as a sort of a final dump for City of Helsinki for all the documentation. So that's why we linked stuff there.